Even if we could travel at the speed of light, it would still take years to reach the nearest star. And that is only the beginning of the problem, because the universe has one obstacle that no civilization can escape: time. And that is exactly what today's video is about. When you look up at the night sky, you see thousands of stars. Some are faint, others bright. Some are already dead, others are only just being born. Our eyes see points of light, but in reality, we are looking into the past. Every star is a window into a different moment in time. The light reaching Earth right now has been traveling for years, decades, centuries, sometimes even thousands or millions of years. So even a simple glance at the night sky is a form of time travel. Whether we want it or not, the universe constantly reminds us that time is its greatest force, and that we are only guests within it. When we imagine the distances between stars, it is easy to believe they are large. But the truth is far more unsettling. The nearest star to Earth beyond our sun is just over 4 light years away. That means light, the fastest thing we know, travels for 4 full years to reach us, and that speed is essentially unreachable for anything with mass. Now imagine how long that journey would take for a spacecraft. Not a probe, not a robot, but a real ship carrying a crew, supplies, and everything needed to survive. Even the fastest probes humanity has ever built move at only tens of kilometers per second. It sounds fast, but in space it is almost nothing. At that speed, reaching the nearest star would take thousands, even tens of thousands of years, and that is only the closest one. Most stars are dozens, hundreds, or thousands of light years away. By human standards, that means only one thing: the universe is unimaginably vast. But space is not the only factor. Time decides everything. Time in the universe does not behave the way we experience it on Earth. Einstein showed us that time is not fixed or universal. It flows at different speeds depending on how fast you move. If a spacecraft could travel close to the speed of light, time would pass far more slowly for the crew than for people on Earth. The travelers might age only decades, while centuries or even thousands of years pass back home. What is one lifetime for the crew becomes entire eras for civilization. From their perspective, they might arrive in the same world they left. From Earth's perspective, they would arrive in the future. And that future would feel just as alien, as if they had landed on a completely different planet. This is one of the strangest and most fundamental truths of the universe. To cross vast distances, you must accept that you are also traveling through time. And time travel in space is not a journey backward. It is always forward, into the unknown. You leave a world you recognize, but you arrive in a world that may no longer exist as you remember it. This is not philosophy, this is physics. And yet there are theoretical ideas that might bypass this reality. One of them is the concept of wormholes, hypothetical tunnels connecting distant points in space. If a wormhole could be created and stabilized, a journey between stars might not take years or centuries. It could take an instant. But for that to work, we would need materials with properties we have never observed, energies far beyond anything humanity can imagine, and physical principles we do not yet understand. Such civilizations might exist. They could be hundreds of thousands of years ahead of us. They might have learned to manipulate the fabric of space and time itself, or they might not exist at all. Wormholes may remain mathematical ideas, forever trapped on paper. But even the possibility shows how unexplored the universe truly is. Now imagine that such a civilization does exist, millions or billions of kilometers away, and it decides to journey toward Earth, not to conquer, not to interfere, but simply because it discovered us, because it detected our signals, because it saw the light of our planet, or because we are just one of millions of potential destinations. Yet no matter how advanced it is, it still faces the same problem: time and distance. Perhaps the journey would take 100 years, perhaps 1,000. Generations might live and die aboard the ship, like pages in a book no one ever finishes. Children would be born in transit, never seeing their home world. Their children would grow up during the voyage, and only distant descendants would approach Earth. The crew would live in a closed world where history unfolds in isolation. Their culture would diverge. Their language would change. Their idea of home would fade into myth. And when they finally arrived, they might discover that the Earth they sought no longer exists as they imagined. Looking into our own past shows how dramatic even a few centuries can be. 300 years ago, we had no electricity, no industry, no modern medicine, no airplanes, and no real understanding of the universe. Today, we travel to space, map genomes, create artificial intelligence, and plan interstellar probes, all within 3 centuries. If a civilization had departed toward Earth 300 years ago, it would arrive at a planet it would not recognize. And if we left today, we would face the same fate when we arrived. Then there is energy. Accelerating even a small ship to relativistic speeds would require more energy than our entire civilization can produce today. To reach just half the speed of light, we would need as much energy as humanity generates over decades. And that is before considering radiation, micrometeoroids, or systems that must function for centuries without repair. All of this makes interstellar travel one of the most difficult challenges any form of life could ever face. Perhaps that is why no civilization would travel in person at all. Perhaps they would send probes instead. Autonomous explorers, silent observers. Probes do not need food. They do not age. They can travel for thousands of years and wait. It is possible such probes already exist, on the edge of our system, at its center, watching and waiting for us to mature. The universe is a vast ocean of time, and we are a small vessel moving at a speed that is insignificant to the stars. When we think about traveling to other worlds, we must accept that what we find there may not be what we sought. It may no longer exist at all, or it may be something completely beyond our imagination. Just as people thousands of years ago could never have imagined the world we live in today. So the simple question, how far away are the stars, when becomes something much deeper. What kind of world will exist when we finally reach them? Because the universe is not only distant, it is changing, alive, unpredictable. And traveling through it means crossing not only space, but time. You leave one world and arrive in another. And that may be why we have not met anyone yet. Not because no one is out there, but because we keep missing each other in time. And maybe that is the most humbling part of it all. Not that the universe is empty, but that it moves on scales we are not built to experience. Civilizations may rise and fall without ever knowing about each other. Signals may cross paths centuries apart. Ships may arrive at worlds that no longer exist in the form they once had. In the vastness of space, timing matters just as much as distance. And sometimes the difference between contact and silence is not technology, but when you exist. If you enjoyed this way of thinking about the universe, consider leaving a like. It really helps the channel grow. And if you want more thought-provoking explorations like this, don't forget to subscribe. Thank you for watching.